My name is Molly, and I am working in Dr. Shrock Lab at UTA within Chemistry and Biochemistry department. Today, I will be presenting the research project that I am currently working on, gas chromatography analysis of odorous compound and waste handling operations using air sampling canister method. Waste handling operations play an important role in waste management, but they also generate gases and odor that can negatively impact the environment and public health by causing disturbing smell, affecting air quality, and causing physiological responses. And the waste handling operations increase is driven by the economic growth, population rise, and urbanization that leading to more odorous emission forming. And because the given environmental concern and the health issue, there are needs of standardized method to access and manage the odor. And this method will help evaluate the intensity and composition of the odors component, which is very important for set up the regulation and mitigating health risk. However, they require multiple sampling techniques and instruments. Also, each standardized method setup is only suitable for one compound group only. So as you see here, ASTM method is only suitable for sulfur because the chemiluminescence detector is only detect sulfur. Therefore, this study is to analyze four categories of 43 compounds group that commonly found in the landfills and have considered thresholds in one analytical run using GCMS TQ8030 in air sampling canister that featuring tech treatment technology to provide almost inert environment that make our sample store for a long period of time without loss, which is ideal for our project. The gas will be pulled into the canister for 5 to 10 minutes using the passive air grab sampling kit, and the sample will be evaluated using the triple quadruple mass analyzer, which is the good mass analyzer for trace analysis. And the MRM method, multiple reaction monitoring method, is used to detect and quantify the specific compound in the complex mixture. And it will provide high selectivity by filtering out interference and monitoring only target ions, and give high sensitivity by improving the signal to noise ratio. Here is the list of the 43 odorous compound divided into 4 different groups: VOC, VFA, nitrogen, and sulfur. VOC is volatile organic compounds, VFA is volatile fatty acid compound, and here's a separate chromatogram of 4 categories of 43 compounds that I extracted from the total ion chromatogram. And those 43 compounds have already determined the target ion transition that already optimized from MRM optimization tool. Their retention time, the odor threshold, the limit of detection, and the limit of detection in gas phase concentration. And here is the data that I got from the sample from local landfills. So this sample, I detect 4 different compounds. I got 1 propanol, dimethyl sulfide, terbunyl, and isobutyric acid. After I detect which compounds that I got from the sample from the landfill, I plot the peak area into the calibration curve to determine the concentration in gas phase concentration and compare to the odor threshold. And from there, I can see that the isobutyric acid and dimethyl sulfide is giving the high impact to the environment or the community around that landfills. And and this is what I'm doing so far, and in the future I will complete the limit of detection table for the remaining compounds and performing quality control to determine the accuracy and precision of method, and also finish generating the calibration curve for the remaining compounds out of the canister. Thank you.